The final answer is 2.243. Up to 3 significant, the answer is 2.24. This one is the final answer. The final answer should be up to 3 significant figures. Now we will attempt question number 5. Trees in a radian forests are classified as tall, medium, and short according to their height. The heights can be modeled by a normal distribution with mean 40 and standard deviation 12. So X is a normal distribution with mean 40 and standard deviation 12 square. Trees with a height less than 25 are classified as short. So X is less than 25. Short. When X is less than 25, they are classified as short. Find the probability that a randomly chosen tree is classified as short. Probability of X is less than 25. First of all, we will convert this one into Z, standard normal variable. Probability of Z less than 25 minus mu over standard deviation. What's the answer?
Sir, -5/4.
Negative 1.25. Now, we will draw the diagram for the standard normal distribution. This one is 0. This one is minus 1.25. And Z is less than minus 1.25. Now, we cannot see the negative numbers from the table. We will flip this diagram. And this one is the required area. Now, this one is 1 minus phi of 1.25 is equal to 1 minus. We will use the table. 1.25, 1.2 and 5, 8944. What's the final answer?
Zero point 1056.
1056. Answer should be in 3 significant figures. So 0.106 is the final answer. Of the trees that are classified as tall or medium, one third are tall and 2/3 are medium. Of the trees classified. Now he is talking only about tall and medium. This one is the normal distribution curve. This one is the mean. This one is the area showing the small ones with probability 0.1056. Now rest of the probability is divided into medium and the large. The medium, the rest of the probability is 0.1056. 0.8944. That is 1 minus 0.1056. If we will subtract 0.1056 from 1, we will get the rest of the probability, rest of the area under the curve. And rest of the area under the curve is 0.8944. This one is the limit for large. Now this area is divided into 1 by 3 and 2 by 3. 1 by 3 are tall. It means 0.8944 divided by 3 is large. And what's the answer?
0.298.
0.298.
298.
And this area is in the middle one, 0.29. Please tell the answer in 4 significant figures. 0.2981.
81.
And what's this yellow area?
0.5963.
0.5963. Now, these are the 3 areas under this curve. One is small, one is medium, and the other one is large. Show that the probability of a randomly chosen tree is classified as small, as tall is 0.298. Correct to 3 dp. We have shown this one, and the working and the working is shown by this diagram. If we have drawn this diagram, there is no need to show any working further. The probability of large is simply 0.298. Find the probability, the height above which the trees are classified as. Find the height, not the probability, above which trees are classified as large. We want to find out this L. Probability of X. We want to write this one in 2 different ways. Probability of X is greater than L is equal to 0.2981, and the probability of X less than L is equal to, please add 0.5963 and 0.1056, or 1 minus 0.2981. 1 minus 0.2981 is comparatively simple. What's the answer?
0.7019.
0.7019. Now, which one should be used? The first one or the second one? Which one will be easier to use? The first one or the second one?
The
And the second one?
Yes, the second one. The table always gives us the area less than any positive value of C. So we will use the uh, expression in which the area is less than the positive value of C. In the first one, the area is greater than the positive value of C. In the second one, the area is less than any positive value of C. We will use the second one. First of all, we will convert this one into Z. We have the probability, we want to find out the value of X. We will use the table in reverse order. V less than L minus mu is 40, ST is 12. Now, A is positive or negative. We will decide this one with the help of these two conditions. If Z is less than A and area is less than 0.5, Z is greater than A and area is greater than 0.5, then A is negative, otherwise positive. Now, in this question, we have Z less than A. We will use the first condition. And area should be less than 0.5, but the area is greater than 0.5. So A is not negative, A is positive. If the area is less than 0.5, we will subtract the area from 1. No, the area is greater than 0.5. We will use this area, this probability, and we will use the table in reverse order. 7019 is the probability, is the area. 7019. 7019. This one is the area. We have got the exact area. And the value of Z is 0.53. So the value of Z is 0.53. So A is equal to positive 0.53. L minus 40. A is equal to L minus 40 over 12 is equal to 0.53. What's the final answer for L?
46.36.
46.36.
36.
46.4. This one is the final answer. This one is the value of L above which the trees are classified as large. Now question number 6. The following are the annual amounts of money spent on clothes to the nearest $10 by 27 people. Construct a stem and leaf diagram. Stem, you know that you have the idea about the stem, and leaves, there is a common stem and there are multiple leaves on a single stem. Now, the method to draw the stem and leaf diagram is we will draw a stem here, and at the place of stem, we will write down the first two digits. For number with 3 digits and the first one digit for the number which is a 2-digit one. So the different stems are 1, 4, 6, 8, 10, 12. There will be a many stem for this one. We will have to choose a different stem. We can ignore the last 0. So the different stems may be (45, 57). Yes, we will convert all the numbers into 3-digit numbers by adding a 0 before the second digit. That is just like this: 0, 0, 0, 0, like this. Now we will write down the first digit in the stem. We will write down only the first digit in the stem. That is first digit. The first digit, different first digits are 0, 1. There is no, yes, there is 2. There is 3. There is 4. And there is 5. These are the different first digits in the stem. Now we will write down the leaves. In the leaf, we will only write the second digit. Now start from the first one. The 0 is written in the stem. Ignore the last 0 because last 0 is same in all the digits. Ignore the last one. Only write the second digit in the leaf section. For the first number, against 0, we will write 1. For the second number, we will write 4 against 0. Third one is 080. Saifullah, what should we write for this one in the leaf section?
Sir, which one?
The fourth one. Sorry, the third one.
Sir, you write a 6 on a stem and 0?
Yes. Mora, for the fourth one, for the fourth entry of the data,
8.
write down 8. And for the third one, the first digit is 10. The first digit is 1. Now we will move to the next row and we will write the second digit in the second row. Second digit is 0. For 130, we will write down Abdullah. For 130, what should be written in the leaf section? Abdullah,
Yes, sir. Sir, could you repeat the question?
for 130, what should we write in the leaf section? First digit is written in the stem. In the leaf section, we will write down the second digit. What is the second digit in the 130?
3.
3. Abdullah, for 140, what should be written in the leaf section?
4.
4. For the next 40, 4, 4. Now, this one for 150, we will write down 1 in the stem. 1 is already written. And we will write down 5 against 1. 5, 5, 5. Then 6, 4 times. And then 7 and 8. 7, 8, 8. This one is the row number 2. Now the digits start from 2, so we will write down the numbers in this row. Abdullah, what should we write against 2 to represent 200?
0.
0. Good. For 210,
1.
1, 5, 7, 8, 3, 1, 4, 5, 5, 7. Now it is very compulsory to write down the key to decode the data. If you want to decode this data, then consider this 3, 1. How can we decode this data? 3 from the stem section combined with 1 from the leaf section will be equal to Abdullah is equal to
3 over 1.
310.
31. Oh,
310. Now 2 from this section stem and 7
270.
to
70.
70. Safiullah, 1 from stem and 3 from leaf is equal to
Sir, 130.
yes. Mora, 0 from stem and 4 from leaf is equal to
40.
yes. So this one is the key is very important because if key is not written, we cannot decode the data. If you will not write down the key while drawing the stem and leaf diagram, you will get 0 mark because the examiner cannot decode the data or your customer cannot decode the data. Should I repeat this? Saifullah,
No, sir, get it.
okay. Mora,
No, sir.
okay. Now this one is part number 1. Construct a stem and leaf diagram for the data. Find the median and the interquartile range. Median is at the position of 50%. Median divides the data into 2 equal parts. There are total 27 people. To find the median for median. First of all, we will find out the position where the median is. We will always add 1 into the numbers and divide with 2. The answer is 14. 14th value is the median. Now 14th value is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. The second 6 is the 14th value. This one is the median, denoted by Q2. So Q2 is 1 from stem and 6 from leaf section is equal to Mora.
Yes, sir.
1 from stem section and 6 from leaf section is equal to
160.
160. So the median is 160. Now interquartile range is Q3 minus Q1. Now Q1 is the median of lower half. This one is the lower half. This one is the lower half. Its median is Q1. The median is the 14th value. Before the 14 values, there are 13 values. Before the 14th position, there are 13 values. So for Q1, 13 plus 1 divided by 2 is equal to 7th value. Now we will count the 7th value 1, 2, 3, 4, 5, 6, 7. The first 4. The 1 combined with 4 is equal to 140. Q1 is equal to 140. Now in the upper half, that is this one. This one is the upper half. There are how many values? There are 13 values in this half. There are 13 values in this half. 13 plus 1 divided by 2. Seventh value. Now we will count the 7th value after the median. 1, 2, 3, 4, 5, 6, 7. This one is Q3. That is 210. Q3 is 210. Now interquartile range is Q3 minus Q1. And this one is equal to 210 minus 140 is equal to 70. 70. This, is there any question in this part 2?
No, sir.
Saifullah, Abdullah.
Yes, sir. Clear.
Now an outlier is defined as any data value which is more than 1.5 of the IQR, which is more than 1.5 IQR above the upper quartile. Upper quartile is Q3, above plus 1.5 of IQR. Q3 we have is 210 plus IQR is 70. What's the final answer?
$315.
2,
$315.
315. Okay. Now, or 1.5 times the interquartile range below the lower quartile. That is Q1 minus 1.5 IQR. Lower quartile is 140 minus 1.5 into 70. What's the final answer?
35.
35. Now the values above 315 are outliers and the values below 35 are outliers. Values above 315 are 450 and 570 and below 35 are is only 10. So the outliers are 10, 450 and 570. These are the outliers. Should I repeat this one? An outlier is defined as any data value which is more than 1.5 above the upper quartile and more than 1.5 times the interquartile range below the lower quartile. If a value is out of these two ranges, then they are considered as outliers. Should I repeat this one?
No, sir.
No, sir.
Okay, question number 7. Find the number of different ways in which 9 letters of the word toe-edged stool can be arranged so that all the three O's are together and both T's are together. Now, first of all, we will write down the identical numbers. There are two T's. How many O's? 3. A, D, S. There is no other one identical. There is no other repetition. We want to arrange the 9 numbers in which 3 O's are together and 2 T's are together. 1, 2, 3, 4, 5, 6. So the final answer is 6 factorial into 3 factorial for 3 O's and 2 factorial for 2 T's divided by the number of repetitions. Repetitions are 3 O's and 2 T's. Final answer is 6 factorial. and is equivalent to, in numbers, is equal to 6 factorial is equal to 720. Please confirm the answer. Abdullah,
Yes, sir.
confirm the answer, please. Is 6 factorial equal to 7?
एक सेकंड एक सेकंड मुझे वो मिल नहीं रहा फैक्टोरियल का एक सेकंड
Bora,
Yes, sir. It's 720.
okay. Find the number of different ways in which 9 letters of the word can be arranged so that T's are not together. T's are not together. We want to arrange 9 numbers in which T's are not together. There are how many T's? There are 3 T's and 2 T's, and there are 3 O's. T's are not together. We want to separate 2 objects. We want to separate 2 objects. We will combine the 2 objects and subtract the answer from the total number of arrangements. We will combine the 2 objects and will separate from the total number of outcomes, total number of arrangements. 1, 2, 3, 4, 5, 6, 7, 8 factorial into 2 factorial for 2 T's divided by 3 factorial for O's, 2 factorial for T's minus 9 factorial divided by 3 factorial into 2 factorial. What's the final answer, Mora?
Just a moment, sir.
Please join. Last part. We have another part of this question. Please join with the previous link.
Okay, sir. This one is 6,720. Wait, no, sir. Wait, no.
6,
Sir, wrong answer.
7.
Wrong answer. Just a moment.